Hi there, my name is Skylar Kulik, and I'll be doing my group's summary for the Civil and Environmental Engineering 291 Python final. So I'm going to go ahead and assume that you're already familiar with the project parameters and what we're trying to accomplish, so I won't rehash that. This is strictly a guide on how to use the program. Now, just a note before we begin, you have to have AnalyzeImages.py installed to a known directory. You also have to have these two files, which will be submitted with our submission, in the same directory as AnalyzeImages.py. If createTable.docx and dependencies.py are not in the same directory as AnalyzeImages, AnalyzeImages will not function. So that's important to note. Now, to actually use AnalyzeImages, we'll go ahead and go to the command line. We'll set our directory to the directory that contains our Python file. Then we can go ahead and call Python AnalyzeImages.py. Then from there, we pass three distinct inputs to the function. The first is a path to the folder containing the photos that we actually want to analyze. The second is the output path that we want for our report CSV summary. Now, you do have to name the CSV, so you can name it whatever you want. Do note, if this name already exists in this folder, it will be overwritten. Finally, you repeat the same process for a .docx summary file. Now, these are written as relative paths to our Python file. We can also use absolute path finding following a process like this. For obvious reasons, this is less convenient, but if you do desire to use absolute paths, just make sure you surround it with double quotes. So once you execute the function, if it is successful, it will tell you that a document has been saved, indicating it's completed. If there's any errors along the way, it will give you an error message telling you exactly what went wrong and offering steps to rectify the problem. So we can see it outputs a CSV containing all desired information, including these two tables assigned using a Llama Vision 3.2 function. Additionally, there's this group ID table. An algorithm will determine which of these coordinates are within 25 feet of each other using a Haversine function, and then it will determine which of those 25 feet pictures are of the same group. If both of those are true, it'll assign the same group ID. Finally, we have the .docx function, which will contain a dynamic table summarizing which image you took a picture of, as well as subsequent pages for each group ID, which contains a description, an average geographic location, the actual type of object itself, and the images of that object. So I hope this helps.